All right, hi folks, this is Larry Maslino. I'm recording a video for Objective 9 in Alex for MATH026. I want to work through a few of these topics. So let's get started. I'm going to come up here maybe to this first one. And so this one is asking me to work out the quotient of two functions. Quotient means division. So they're going to ask me to divide these two functions. So what I'm noticing in this example is, let me set this up here. They're asking me to really first set up g of x on top and h of x on the bottom. So what I'm going to do to set up this fraction is on the top, g of x is defined as x minus 3. On the bottom, h of x is defined as x minus 2 times x minus 1. So I'm going to write this function as a quotient. Again, that just means set it up as a division, which I can write as a fraction. All right, but now what they want is they want me to evaluate when x is negative 6. So now what they're asking me to do is evaluate this function when x equals negative 6. And they write it as g over h of negative 6. That's just another way to say plug in negative 6 anywhere you see x. Okay, so let's do that. I'm going to take this x here and replace it with a negative 6. Go down to the bottom here. I'm going to replace this x with a negative 6. And one more here. Replace that x with a negative 6. Now I'm just going to work this out. On top, negative 6 subtract 3 is a negative 9. On the bottom, negative 6 subtract 2, that's a negative 8. And negative 6 subtract 1, that's a negative 7. So this looks like negative 9 over. Now on the bottom here, I have a negative times a negative. That's positive. So I'm ending up with negative 9 over 56. Okay, and that's the answer for this problem. All right, let me go to part B. Part B says, find all values that are not in the domain. Well, for not in the domain, what that really means is keep in mind that you cannot divide by 0. So I cannot let x be any value that would result in a 0. So to figure this out, what I'm going to do is I'm actually going to set the denominator equal to 0. And that's going to tell me what values I should exclude from the domain. The domain is really the allowed values for x. But I want to figure out what's not allowed. That's what they're asking me here. What's not allowed? Well, what's not allowed are any x values that cause the denominator to be equal to 0. So I'm going to take this denominator, which is x minus 2 times x minus 1, and set it equal to 0. Well, anytime I have one parenthesis times another equal to 0, I'm allowed to set each parenthesis separately equal to 0. So I'm going to break this up into two equations. Here I'll add 2 to both sides, so x equals 2. Here I'm going to add 1 to both sides, so x equals 1. So I am not allowed to cannot allow x to equal 2, and I cannot allow x to equal 1. Those are the values that are not in the domain. Because if I did allow x to equal 2 or x to equal 1, I would end up dividing by 0. All right, so that's this question. Again, keep in mind quotient means division. Really, they were asking me here to set up a fraction. All right, let's go to the next example here. This is going to also ask me to work out some different expressions using s and t. All right, so first thing I'm noticing is they're giving me s. The function s is x to the third. The function t is 2x squared. So let's go to part A. Part A says, work out s minus t of x. Well, that's really a fancy way to say, take the function s and subtract the function t. So you got to be careful with this notation. So they're really asking me to work out s minus t. Well, all I'm going to do then is drop in x to the third for s, 2x squared for t, and that's the answer. Let me go to part B. Part B is asking me to multiply. So they're saying s times t of x. Well, that's shorthand notation to really take s of x and multiply it times t of x. So again, I'm going to drop in x to the third for s and 2x squared for t. And I could just clean this up a little bit because x to the third times x squared. That's the rule where you add the exponents together. So this is going to be 2x to the 5. That's the answer for this part. All right, let me go to part C. Part C says, what is s plus t of negative 2? Well, for part C, first, I'm going to figure out s plus t of x. Really, that's going to be taking s of x plus t of x. Okay, so let me plug in s of x is x to the third. T of x is 2x squared. But then they want, what is s plus t of negative 2? So really what this is asking me to do is replace x with the number negative 2. So I'm going to do that. That's going to be negative 2 to the third plus 2 times negative 2 squared. All right, so let me work this out. Negative 2 to the third is a negative 8. And negative 2 squared is a positive 4. So it looks like I'm ending up here with negative 8 plus 8, which happens to be 0. So the answer to part C is 0. Okay. Folks, just a reminder, please remember that you have the explanation available. So when you're working here in ALEKS, please check out the explanation. In this example, this notation they used was a little confusing. So you might not be familiar with this notation. That's where the explanation would be a big help. Let me click on explanation. So notice they're telling you how to think about this notation. Notice here they said s plus t of x is really s of x plus t of x. And that's why I think this explanation is very important to check out, because it'll explain some of the notation and some of the terminology. All right, let's do a few more. Let me come here to this one. It says, write an inverse variation equation that relates x and y. All right, well, for this, let me point out to you that there are two kinds of variation. Well, there's more than two, but let me mention two types of variation equations. There's something called direct variation. Direct variation means as one quantity increases, another quantity increases as well. And we write that as y equals k times x. An example of this might be the more hours you work at your job, the more money you earn. That's an example of direct variation. Indirect variation is when one quantity is increasing, another quantity is decreasing. And we write that as y equals k over x. An example of this might be, as the age of your car increases, its value decreases. So those two quantities are moving in opposite directions. Okay, excuse me, I'm going to say inverse variation here. Sometimes we say indirect, but I'm going to say inverse to match what ALEKS says. All right, now in these equations, you need to find k. K is called a constant of proportionality. We need to find k. Well, the way this is set up is ALEKS is going to give you enough information for you to calculate k. So I'm going to come over here. Let's do part A. As soon as I see inverse variation mentioned, I'm going to write that as y equals k over x. All right, but I want to find k. But notice they told me that y equals 3 and x equals 6. So I'm going to plug those in. Y is 3 and x is 6. Now I can solve for k. I'm going to multiply both sides of this equation by 6, because that'll let me cancel out this denominator. So it looks like I'm ending up with k equals 18. So now I can write the answer to part A it's going to be y equals k over x, but I know k is 18, so I can write it as y equals 18 over x. All right, let me go to part B. Part B says find y when x is 16. Well, all that's asking me to do is take this equation and replace this x with the number 16. So I'm going to end up with y equals 18 over 16. And I could simplify fraction. I'll divide top and bottom by 2. So this is 9 over 8. So that's the answer to part B. Okay, so for these variation equations, you want to be able to start off by writing either y equals k times x if the problem mentions direct variation, or write y equals k over x if the problem mentions inverse variation. That's really the first step. Then the next step is going to be to find k. And usually you'll be given enough information in the problem to allow you to calculate the numeric value for k. Okay, again, if you're not sure how to get started, remember to review the explanation. Notice here it says, set it up as y equals k over x. Then they plugged in the specific numbers for x and y here, and they found k was 18, and they wrote the equation as y equals 18 over x. Okay. What if we do a word problem along the same lines? All right. So they're giving me some information in chemistry. There's a formula or a law that says, Boyle's law says, the volume of a gas varies inversely with pressure. Okay, so I'm going to try to write an equation, and I'm noticing it says inverse variation. Well, if it's inverse variation, I know I'm going to write it as y equals k over x. In this case, y is going to stand for the volume, and x is going to stand for the pressure. Now, instead of writing it as y equals k over x, we could write it as v equals k over p in order to make the letters, a little more meaningful to this example. Either way, right? Writing it like this is okay. Writing it like this is okay. Totally up to you. All right, well, here's what they're giving me. Remember, now we want to find k. It says the volume is 8. The pressure is 200. All right, so let me plug in. The volume is 8, and the pressure is 200. Let me solve for k. Well, to solve for k, I can multiply both sides by 200 to cancel out this denominator. So it looks like k equals 1600. So now I can write the equation as v equals 1600 over p. This is the variation equation where I plugged in k 1600. Now I can answer the question, what is the volume when the pressure is 80? So now they're just asking me to plug in 80 for p. And if I do that, it looks like v equals 20. Okay, so what this equation is telling me is as the pressure goes up, the volume goes down. So there's this inverse relationship. All right, let me look at another example here. How about, by the way, folks, remember, please email me if you have any questions on these topics. Let me go to one more here, classifying the graph of a function. All right, so they're giving me these different functions, and they're asking me to think about the description. All right, well, let me give you some general guidelines. Now, anytime you see f of x or g of x or h of x, you can really think of this as y if you want. So y and f of x really are interchangeable. Okay, so let me give you some examples. when you see y equals a number, this graph is a horizontal line. If the equation was x equal a number, like x equal 5, this graph is a vertical line. Okay, what if I had an equation that has both x and y in it, like y equals 3x plus 2? Well, this graph is going to be a line, but I'd like to know if the line has a negative slope or a positive slope. Well, the way to know that is compare this to y equals mx plus b. This number in front of x is the slope. So in this example, m equals 3. Well, that's a positive number, right? That's positive 3, so that means positive slope. So this graph is a line with a positive slope. Okay, let me do another example. How about if we had, let me come over here. How about if we had an equation like y equals negative 5x plus 7? Well, again, I'm going to compare this to y equals mx plus b. By the way, this is called the slope-intercept form of a line. You might remember this if you took MATH026. M is the slope, and this b number is called the y-intercept. That's where the graph crosses or intercepts the y-axis. Well, in our example, the slope is negative 5. And of course, that's a negative number, so it's a negative slope. So this example, this graph is a line with a negative slope. All right, how about a parabola? Well, a parabola is an equation that has x squared in it. So like x squared minus 7, or y equals negative 3x squared plus 2x plus 4, let's say. So anytime you see an x squared in the equation like this is the graph is going to be a parabola. So these two examples here, the graph is parabolas. Parabola means a curve, and the curve is going to either open up like this, or the curve might open down like this. So how do you know whether the parabola or the graph opens up or opens down? Well, what you do is you look at the number in front of the x squared. If the number in front of the x squared is a positive number, then the graph opens up. If the number in front of x squared is a negative number, then the graph opens down. All right, so now let's go to these examples. Part A is y equals negative 2. Remember, I'm thinking of f of x as y. Well, if y equals negative 2, anytime I have y equal a number, that graph is a horizontal line. So the answer to this one is horizontal line. Let me go to part B. Part B is y equals 4x squared minus 2. Well, if y equals 4x squared minus 2, I know this is a parabola, because anytime I see x squared in the equation, that tells me parabola. Does this open up or open down? What I do is I look at the number in front of x squared. If that number is a positive number, like it is here, that tells me the graph opens up. If this had been a negative 4 in front, I would know the graph opens down. So for part B, this is a parabola that opens up. All right, let me go to the last one, part C. I could think of this as y equals x minus 1. Well, if there's just an x in the equation like this is going to be a straight line. And what is the number sitting in front of x? Well, there's no number written, but I could put a 1 in front. And notice that means the slope here is m equals 1, but that's a positive number, so this means positive slope. So this graph is aligned with a positive slope, so that would be the answer there. All right, folks, hope this is helpful as you're working in Objective 9. Please let me know if there's any questions.